Good morning, students. Here is our next topic, that is solubility of solid in liquid. First, what is solubility? See, if 100 gram of solvent is present and in this 100 gram of solvent, how much amount of solute completely dissolves and makes a saturated solution? That amount of solute is known as its solubility. Means amount of solute required to make a saturated solution in a given 100 gram solvent at a specific temperature is known as its solubility. Solute may be present in grams or in moles. Similarly, solvent we can take in 100 gram or 1 liter. Solubility can be expressed in the form of gram solubility or in molar solubility. If solute present in grams, then it is known as gram solubility, and if it is present in moles, then it is known as molar solubility. For example, if 10 gram NaOH completely dissolves in 100 gram of water and makes a saturated solution, so this 10 gram NaOH is its gram solubility. Now we know moles is equal to weight of the substance upon its molecular mass. Here weight of the substance is 10 gram and the molar mass of the NaOH is 40. So 10 by 40 means 0.25 moles. So molar solubility is 0.25 moles. Clear? Gram molarity is divided by molar mass. So we can get molar solubility. And molar solubility multiplied by the molecular mass of solute, then we can get gram solubility. Clear? Here we use one term, that is the saturated solution. So what do you mean by saturated solution? See, saturated solution means no more solute can be dissolved. Means if the gram solubility of NaOH is 10 gram, means in 100 gram of water only 10 gram of NaOH completely dissolves. Clear? And it makes a saturated solution. Means now if we add another 2 gram or 3 gram of NaOH, then the rest amount, that 2 or 3 gram of NaOH, will deposit at the bottom of the container. Means this extra 2 or 3 gram of NaOH will not completely dissolve in the solution. So this solution will be a saturated solution. Clear? Saturated solution means what? Solution which contains maximum amount of solute which dissolves completely in a given solvent. Clear? See, the solubility of NaOH is 10 gram. But the solubility of NaCl is not 10 gram. Means the solubility of different compound will be different, and it will depend upon the nature of the solute or nature of the solvent or temperature or now factors affecting the solubility of solid in a liquid. First factor is nature of solute and solvent. We know like dissolves like. Means a polar solute is more soluble in polar solvent and non-polar solute is more soluble in non-polar solvents. Means maximum ionic compounds are soluble in water, whereas maximum covalent or organic compounds are soluble in non-polar solvents or non-aqueous solvents like benzene, ether, carbon tetrachloride. Here the intermolecular interaction between solute and solvent should be similar. Means polar solute means dipole-dipole interaction is present, and polar solvent means dipole-dipole interaction is present. So here polar solute will be more soluble in polar solvent. Similarly, in non-polar solute, van der Waals forces are present, and in non-polar solvents again van der Waals forces are present. So here non-polar solute will more soluble in non-polar solvent. For example, NaCl or NaOH. NaCl is soluble in water and makes a salt solution, but NaCl is insoluble in kerosene or petrol. If we add NaCl in kerosene or petrol, then NaCl will settle down at the bottom of the container. Means NaCl is insoluble in kerosene or petrol. See, NaCl is an ionic compound. Water is an again polar solvent, but kerosene or petrol is a non-polar solvent. That's why NaCl is insoluble in kerosene or petrol. Clear? So for this we have to remember like dissolves